Alrighty. Happy Monday again. So we've got Project 3 to talk about. We've got objects and classes to talk about. And I think we'll wait until Wednesday for the final project, if that's all right, because otherwise I won't have any time to talk about objects and classes, and we need that for the project. So should go pretty well. So let me fire up Visual Studio here, and we'll take a look at Project 3 and see if we can't knock that out pretty quick here. Uh, New project, console app, Project 3. So we're going to do this little ticket master program. The idea is to read and write files, I need to know how I want to read them to know how to write them, or I need to know how I want to write them to know how I want to read them. Right? They go hand in hand. So however I want to order this data, we can do it that way. Now, a couple different options, right? Doing one line per piece of information is probably the quickest because that way every ticket will have 3 lines, right? Because it has its ticket number, it'll have the purchaser's name, and it'll have the confirmation code, right? Blank tickets have nothing for the purchaser's name, and they have 0 for the confirmation code. So for option 1, when I set up a new show, I'm going to get X number of 3-line sets, right? And this way I can have 3 different vectors. We'll learn a better way today, actually, on how we could do this, not having to rely on 3 different vectors and use the same index, because that's, it's not great. It works, but there are better ways to do it. So when we go to sell tickets for the show, we have to go and read that file, load up our 3 vectors, and then let the user try and pick one of those tickets, right? The ticket number or like seat number, turns out if we write them in order and read them in order, it lines up very, very, very well with the index. That's a nice little lifesaver. We don't have to look at every ticket to find ticket number 27. I know it's at index 27, right? Because they line up there. If you start with ticket number 0, which we're going to because we're programmers, we can start with 0 and people can think we're crazy. And then for number 3, we just read the file and spit it back out, maybe in a slightly nicer format rather than line, 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 right? Make it look a little prettier. Um, I didn't specify it had to be pretty. So as long as you're like displaying the contents of the file, you're fine. You get your points here. It's probably better to make it look a little bit prettier because, um, again, one of the sad truths in life here is people really only care about their job as much as they get paid, right? So the person who's checking people in for a show, if they've got to like read just this mishmash of line, 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 and you make it hard for them, they're not going to care, right? Like, oh, sure, okay, right. But if you make it easy for them, it's easier for them to do their job, right? So we want to make it easy for people to do their jobs because that's what computers are for, right? We want to make computers do the hard stuff to make it easy for people to do what they need to do, right? Okay, so let's we're gonna need a couple imports here, and I can never remember which one is which, so I'm just gonna go copy all of them real quick off of one of our examples because we need F streams and we need uh, all that nonsense. Let's see. There we go. So all of these ones here, we can add some imports. IO string. I don't think we'll need the string streams for this one. We'll use string. We'll use IO manipulation. Probably not. I don't think we need to do any rounding or anything. And then the file streams to do our file streams, right? Okay. So all of this will happen in some sort of menu, like what do you want, option 1, option 2, or option 3. So we'll have an int for, I don't know, the choice is 0. And while my choice does not equal, I don't know, like 4 to quit, something like that, we can keep on going, right? We can do that. So then we can see out after 1 to set up a show, sell it's 4, or maybe just 1, right? Any way you want to do your menu, right? It's going to be fine here. Oh, using namespace. There we go. Base standard. Okay. And an end line, and then 2 sell tickets for a show, and an end line, 3 print report tickets for a show, an end line, and see out quit. Something like that, right? And I can see in on choice, right? So we've got our input now. Then I can quickly say, hey, if choice is equal to 1, let's do the 1 thing. So we need the show name, right, to go and set up this file. So you can see out and enter the name, enter the show name. Now, we're going to do this 3 different times here. So if you're thinking about it, you might think, oh, well, I don't want to do this more than once, right? So we can make a function for it. Not a very interesting function here, but like get show name, right? We can see out the show name, and then line. You can have a string for show name. You can see in on show name. Now, this may or may not have spaces, right? Like some movies have spaces in the titles, so it's probably a little safer to do a get line. Right? We'll get line with cin and the show name, and when we're done, we can return show name. Right? Can do that. Now, remember, if we mix and match cin and get lines, though, things get weird, right? So it might be a little funny. We'll see what happens because generally, when you see an ints and then you try and get strings later, it can cause some trouble. Okay, so I think we can clean that up after here. We'll look at it after. So I don't need a string here, or I don't need my own cout, so I can just say, hey, string for show name is equal to get show name. Right, so we should get a string back. Again, we'll do this multiple times, so I'm just trying to work ahead here. So we got the show name. So then we need to ask how many tickets, right? So an int for number of tickets, and then we can see out how many tickets you going to sell. And we can see in on number of tickets. Again, it might be a little funny. We'll come back to this and see. We can run in the debug mode and see what happens. Right. Now I can open the file and write a bunch of blank tickets. Right. So to open the file, again, I'm just going to go copy paste what we have in here. Let's see. This is our. It's just reading. What? Goodness. Did I not? Chapter 6. Didn't I have another set of examples? There we go. Streams. Okay. That's the one I wanted here. Because we want to write this data here. So an OF stream for output file, given a file name, if it's open or not, then we can start writing to it. So make our OF stream open. Now it's not just retirement.txt, right? It's going to be show name. We probably want to add in here the .txt, right? Or maybe we add that in with the get show name because I don't want to have to add the txt myself every single time, right? So I can say show name equals.txt, and I can return that. So I don't need to add it myself, right? Because if I'm going to add the txt every time, might as well just add it here. Right? I've got the function doing this for me here. So we'll try and open the file. If it is not open, we can't really return anything because we're in a main here, so we can like return 1 or something here. Or maybe we just output an error. Like cout able to open file. Sure, why not? So really, then all of this will be in an else. Oops, that's not how you spell else. So if it did open, great. Then the rest of my option 1 happens here in the else. So now I can loop. So for int ticket equals 0, ticket, or I guess this is ticket number, right? Ticket number 0. Ticket number is less than the number of tickets. Ticket number plus plus. I'm going to write a bunch of things to the file. Right? I'm going to take my output file and I'm going to output to it here the ticket number and an end line. Right? That goes on one line. I'm going to take my output file. I'm going to write to it nothing, right? Because there's no purchaser's name. It's really just an end line. An output file, I'm going to write to it a 0 for the confirmation code. Right? So every ticket gets 3 lines. Right? Gets the ticket number, there's no purchaser, and 0 for the confirmation code. When we're done with our file here, right, in this else block, output file dot close. Close it up. Right? If it didn't open, then it doesn't really matter here because it failed. We'll go ahead and give it a close. That's option 1. Right? So then else if choice is equal to 2, let's do option 2. So 2, we need to go and read this file. Right? So again, we need to get the show name. So let's get the show name. And I'm going to make a vector of type int for ticket numbers. That's right, we got to include vector here. Let's see, add include vector. We need a vector of type string for purchaser's name, purchaser names. I don't know. Customer name, sure. And a vector of type int for confirmation codes. right? So we're setting up these vectors. Then I can go try and read through them here. So now we're going to try and read our file. So we're going to use an input file stream, try and open it up. If it's open, let's go ahead and do something. Don't need all that stuff. So we're going to try and open the show name file. Whatever it is, we're going to try and open it. If it didn't open, could not open file, or we don't sell tickets for that show. And an end line. And again, no return. That's it. Everything else happens in the else here, right, for this option, because it'll kick us back to the menu, right, because that'll be the end of this. If it did open, then now I need to start reading until I run out of stuff to read, right? So we got a couple different options here. So if we didn't reach the end of the file, sort of thing, we can check for it. We can check while we're not at the end of the file. Uh, that's probably pretty fine. So while we're not at the end of the file, that should probably work for us. While input file stream dot is end of file EOF. There we go. While it's not the end of file here. Now I'm going to use getLine for the string here, right? But I should just be able to see in these essentially, or input them here. So I'm going to take my ticket numbers. I need an int for the ticket number. I need a string for the customer name. And then I need an int for the confirmation code. Confirmation code. Confirmation code. Goodness. Right? And then I can take my ticket number, no, my input file stream to the ticket number. I can take, now I need to get line right on the customer's name because they might have given me a first and last name, right? That might be a little funny here. So we'll try get line, given the input file stream and the customer name. And we'll take our input file stream, nope, input file stream to the confirmation code. Once I've got those, I can add to my vectors, right? So I can take my ticket numbers, and push back the ticket number. I can take my customer, what do we call that one? Customer names. That should be plural there. Oops, customer names. There we go. Push back the customer name. I read one out, and then I'll take my confirmation codes, and push back confirmation code, singular. There we go. Right, and I just keep on reading as long as I haven't got to the end of the file. I think that'll probably work. Right. So when this loop is done, we should have read the whole file. We should have our vectors loaded. Right. Then we need to tell them, right, the largest ticket number they can buy. So see out. We have, that'll be my, I don't know, ticket numbers dot size. Right? That is the number, right? Tickets to sell, or tickets for the show. Oh, sure. And then we need an int for ticket number. What ticket do you want to buy? See out. What ticket do you want to buy? Oh, goodness. Buy. And line. We can see on a ticket number. Now we need to check, see if that seat's available, right? So check and see. If the confirmation code's 0, then that seat's available. That's probably the quickest, easiest for us to check. If it's not available, tell them to pick again. Okay, so we can check, hey, if my my confirmation codes at the ticket number, right, because that is where this ticket is at the vector, is equal to 0, we're good, right? Otherwise, tell them no, right? Or maybe, how about while it's not 0, or while it is not 0, we'll tell them that ticket has already been sold. What ticket do you want to buy? Right, maybe we'll just keep them in a loop. Right, we could do that. We might also want to check to make sure we're getting somewhere that's inbounds, right? Because if I give them ticket number 10,000 and I only have 200 tickets for sale, it's going to crash.
Was for the max ticket number that they can buy as Mac, we have to figure out which or what the highest available ticket number is, not like how many tickets are available.
Well, we probably numbered them 0 through whatever,
Right.
and minus 1.
But
So,
we had to not include like if someone already bought ticket number five of
well,
five, we
we
had
would
to
have read that out of the file. So this is like max number of tickets. It's like that's the highest ticket number, right? So like, hey, I have 200, there's up to 200 tickets, or I don't know. But the idea was you can enter a number between 1 and 200, or 0 and 199. Like, tell them what to enter rather than make them guess. If you did more complicated, that's cool.
I tried more complicated, but
Okay.
seeing that I could have done this at like
So we probably want to check that ticket number is less than ticket numbers dot size, right? If that, or it's here. I don't love this error now then, so that's a little awkward here. So we can say, hey, if my ticket number is greater than or equal to ticket number dot size, out that number ticket number is invalid. Otherwise, it must be that that one's already been sold. That's probably a little more complex than we needed, but again, more helpful error messages are useful for people, right? So what's cool about this, remember we talked about this does the short circuiting. C++ is going to be lazy here. If this is true, I'm sorry, no, this is greater than or equal to, goodness gracious, greater than or equal to size. If this is true, the while loop is going to run no matter what because it sees an or. It's not going to bother even checking over here because it's found this was true, right? If you're ORing together, the first time it finds a true, it just stops evaluating. It doesn't care what else because it doesn't matter. We're ORing it together. And what that means is if I give you an invalid index, immediately I'm not even going to check that index. I'm going to keep it from crashing. This is a nice handy way that you can rely on the short circuiting. You don't have to have a first check that it's valid and then actually go look at the index, right, to make sure it's valid here. Um, we could also put if it's less than 0. I don't think many people enter negative numbers for ticket numbers. Users do some weird stuff though, and sometimes cats jump on their keyboards. So, we got to be a little careful. All right, so what ticket you want to buy? Okay, great. So eventually we'll get a ticket number when this loop will stop, when it is valid, is the idea here. So we can see out, enter your name for the ticket, end line, and then we'll have a string for customer name, and then we'll get line, right, using our CN and the customer name, because it might have some spaces here, right? And then I'm going to take my customer names at the ticket number, and I'm going to assign it the customer name, right? So go and put their name in here for that one. Then we need to do the random confirmation code. So init for confirmation code is rand, and then we want to do modulus. Now, there was a formula for this we talked about way back when, right? It's your max minus your min plus the min, because we want a range of values. We want essentially 800,000 values, because we want from 100,000 to 999,999, or is it 900,000? I think it's 900,000 values, right? 900,000 values, because we chop out the first 100 there. So I want modulus 900,000 plus 100,000, right? Because modulus 900,000 will give me numbers up to but not including from 0 to 899,999 when I do this modulus, right? Rand will never give me, right? When I modulus by this, I'll never get this value. So I'll get between 0 and that, whatever the remainder is. And then I add 100,000 to it to bump up the minimum. Now I'm at 100,000. And then if the previous top was 8,999, the new top is 999,999. Just some silly arithmetic here. And I'll take my confirmation codes at the ticket number, and I'll set it equal to the confirmation code, right? Or you could just do this right here if you want it, right? You can just do it in line. Either way is okay. Not too big of a deal one way or the other, right? Now I've got that ticket sold. I have to go rewrite the file, right? I'm just going to rewrite everything in the file here. So for int index 0, index is less than ticket numbers dot size, index plus plus. Oops, and I forgot to close the file right after we did this. Input file stream dot close. Make sure we close it. That's an important step. All right. So now I'm going to try and rewrite that file here. So let's go back to the file open here. Output file, to the show name. It probably will do this. I don't know, we should probably still check. I guess that's probably a good idea. Given the show name, output file to update. This one's real bad if this happens, but it probably won't happen here. So then else, you can go through um, or unable to save ticket sale. Please try again. Good thing we didn't take any money from it, right? Sure. All right, so now we'll loop through and we're going to take each of these items here. We're going to output, right? This will overwrite the file when we open it because we didn't add it for append mode. We're just going to overwrite it with my ticket numbers at the index. Right? I mean, this is going to be 0 through whatever again. If you just want to use the index, that's probably fine. Either way, it'll be okay. And then we'll take our output file and we'll add the customer names at the index, which again, mostly will be blank here, but some of them will have some values here. And then my output file, my confirmation codes at the index, and an end line. Go ahead and write the file, and then we'll close it. Output file, close when we're done. So this rewrites 3 lines per ticket, right? I've only updated one of them, but we don't know how to just go update just those 3 lines yet. It's okay. We'll get there eventually. Or use an actual database. This is just an exercise using files, right? So we open it and read it. We update one of them in the vector, and then we go rewrite our vectors. Not too bad. Right, and that's option 2. So option 3, let's see, is that this one here, right? This is my choices 2, right? So I want this line here, else if choices 3. Now I already read the file. I know how to do that, right? So that's this one here. Go read the file. Right, so I'll just copy this in here. Oh, we need the show name. I missed that line. Shoot, show name. Get show name. Now I don't need to put them in vectors when I'm just spitting out the file here, right? So until tickets for that show, while it's open here, again, I don't need to push them back. I can just now see out. And we can say ticket number and the ticket number, maybe a space, and then customer name, and another space maybe, and then the confirmation code, and the confirmation code, and that line. We'll just dump all that on one line. That's a little bit ugly here. So we'll do ticket number, customer name, confirmation code. Right. That way it looks a little prettier on my report. If you wanted to get fancy, you could just skip all the tickets that have no confirmation code and only output the ones that have been sold. I didn't ask for that, right? I just said run a report. Show them all the names. That's fine. Should we try it? See if it works? All right, let's give it a run. Uh-oh, build errors. No matching main file. Uh-oh. Oh, and my copy paste. Yep, I forgot. So that's my choices 3 is over, right? Okay, so this else needs to, the while loop needs to end. The while loop ends, then the else ends, and then my choices 3 ends, and then my main ends. Oh, what's my 4? There we go, main ends. I think we're just missing one. All right, so let's set up a show. Let's for trolls. Yeah, we're having an error with our input here. So mixing and matching cin and getLine is a little bit messy. A little bit messy here. Let's see. So when we get the show name, let's see. So after we see in the number of tickets, let's see. What did we do wrong here? So after choice, I think then we can do a string for garbage or something. Garbage. I think after we see in, we can get line cin garbage. Seriously? Wow. Just by, just by it like it ignores it though. Trolls. What?
I understand.
It gets upset. I don't know why. So let's say 200 tickets for trolls. And let's see. I should now have a file here. Um, where's my? I guess I'll need to stop it here. And let's open this in Explorer.
Yeah, it never does it in main. It always does it in like one of the other functions.
Okay. So this looks correct, right? Up to ticket 199. Right. So we got what we'd expect for that. Now we should be able to sell one of those tickets for option two.
Which
Two.
I guess this is like a dumb thing to argue, but since we put in 200 tickets, would we want to do like uh +1 so that the first ticket is one instead of the ticket?
You could. So if you want your people to buy tickets 1 to 200 instead of 0 to 199, go for it. Right. We're all programmers, so we know everything starts at zero. So when I have 200 tickets, you know you can't enter 200 because obviously,
Right. It'll be
yeah,
zero.
no, it's anyway, it's fine. Not too particular there. All right. So we want trolls. We have 201 tickets. 201 tickets. Well, that's the size of my vector here. So something read a little bit wrong here. So I think that very last end line probably got read as something. That's unfortunate. Okay, so that's fine. Yeah, because we didn't actually get to the end of the file. Because the very last end line, when we do a CIN on confirmation code, there's still something left, right? And then it's going to go try and read that, which was just an end line.
Okay.
I think that's probably what's happening there. Yeah, mixing and matching is a little bit awkward here, so it's probably okay. Um, so what do we want to do? So maybe after we're done, then let's see. Let's ticket numbers. Hmm. All right, just for fun, let's see. I'm going to put a breakpoint in. Let's try that again. Let's see what the size of those are. So let's go two for trolls. All right, so my customer names is 201, confirmation codes is 201, and ticket numbers is 201. So too many here. So after I've done that, I think it's just reading garbage. Right, when we got that last end line there. So after we've read all of them, I'll take my ticket numbers and I want to pop one off. Take my customer names, pop. Let's take one off, and we'll take our confirmation codes, and we'll take one off.
What is pop like?
So vector pop back, back. Let's see what it says. Nope, that's not what I wanted to do. Increase. Shoot, I wanted to remove. Vector remove. Last item.
That's it.
Yeah.
Pushback. Was the pop.
What? I'm sorry.
If you go back to the
Oh, was I reading the wrong one? I was. That was pushback. Pop back. Yeah. Removes. Okay. Yeah. Removes the back item. Pops it off. Sorry. I don't know how to read. Yep. So that'll remove the extra run for us. Probably make life a little easier for us. All right. So let's give that a run. So two patrols. And our arrays now are size 200. That looks right. All the confirmation codes be zero. All the customer names are zero. All my ticket numbers should just be right, not very interesting here. Through 199. So it looks correct so far. So let me take that out and continue. We have 200 tickets to sell. What ticket do you want to buy? How about ticket 42? And again, we've mixed and matched. We did some silly things. So goodness gracious. Okay. So after we get the ticket number, then I need to get line, CN on garbage. That's why this is so annoying. Mixing and matching is obnoxious. So the very last CN, remember when you're inputting with integers, it leaves that enter key because that's a character. You only wanted an integer, so it just reads up to the integer. So we have to get line to get the enter key out. So the next time we can get line and actually get a value here. Let's give that a run. Trolls, 42. Uh-oh, the ticket's already been sold. Remember, it didn't prompt for my name, it just got an enter, but there's going to be a confirmation code there. Right, if I look at trolls, there should be a confirmation code for ticket 42. Right, it was just sold to nobody. Because again, it didn't ask for my name because it had that enter key there. So when I did the get line, it got my name was nothing. Right. We'll put Eric in here for fun because we can do that. All right. So that one didn't was already sold. How about ticket number what? Like 200 or 201? Ticket number's invalid. What ticket do you want to buy? Okay, that check's working. It'll crash. I didn't fix that. Yeah, I didn't. I figured people wouldn't do that. That's probably my bad. Like -1. Oh, it says invalid. Interesting. Why would it say it's invalid? Ticket number is invalid. If ticket number is greater than ticket size. Oh,
Furry thing and roll back a negative number to a.
I'm super confused. It shouldn't have done that, right? For a -1? Ticket number. Huh. I don't know. Let's put a breakpoint in. Let's try that again. -1. We're still in debug mode, right? So ticket number is -1. Step. How did uh, -1 greater than or equal to ticket size? What just happened here?
What the other or?
That's
Something else.
if the confirmation code's not 0. So that's why ticket 42 told us it was already been sold.
Right.
Why? Huh. I think we broke it. Ticket number size. Right? Ticket number size is 200. Ticket number size gets me a value. I'm real confused there. Sure. We made sure we can't do negatives. Bonus. Let's try it again. 2 patrols. Are we still in debug mode? What happened here? Did I break it? Oh, it's in a loop reading for. Okay, so our read loop is having some trouble here. That's unfortunate. We're just reading forever. Our memory is just growing and growing and growing here. So finally, this thing's working here. Eventually, it's going to crash when my computer runs out of memory, I think. So we just keep adding garbage to our vector here. So if I pause it here, my vector size is big right now. That was the pause button there. While it's running, you can pause. Super handy. Yeah, so we just kept adding and adding and adding and adding and adding. So zeros for confirmation codes. That's what you should have 1 in here. Oh, we don't have any in here. So it just broke. Right, we never got that confirmation code for ticket 42. Customer names. Never got Eric out. So sad. We had Eric in the file, I thought. And ticket numbers. We stopped at ticket 42. Just stopped reading here. Right. Let's see. So ticket 42 should have read Eric and then the confirmation code. But it stopped. Why did it stop? Good line for a file stream. The customer name. All right, let's just put my name in up at ticket 1 here. So ticket 0 for Eric, 100,000. We'll see what it does here. Trolls. Okay, so I'm trying to read the file here. So we got the ticket number with 0. And when I call get line, I get no name. And the confirmation code wasn't able to read it. Why couldn't it have read that?
It's right. It's 0.
Must have stopped at 0. Wonder. We have to do the get line again. File stream. Garbage? Let's try that. See if we can get out a garbage value first. Because we're mixing and matching file reading too. Yeah, that's confusing it. Now it's customer name. Okay, now customer name has Eric. Yep. So same issue. We read an int. There was a new line. So we got customer name as the new line. and then got stuck. Looks like he got stuck somehow. I don't know. That's interesting. All right. Oh, because then it couldn't input the confirmation code because then it was on Eric, and it just stalled out there. So I guess reading to the end of the file it's a little bit problematic, but I'll probably be okay. So after we do that, then we should also then get line the file stream to garbage. All right, let's try that. Two trolls. All right, ticket 0. Let's take out our ticket number should be fine. Ticket's already been sold. Okay, good to know. Good to know. So ticket 0 has been sold. How about ticket 1? Eric Chernesky. And it worked. Or maybe it did. Printer reported the ticket. Trolls. Oh, we forgot to fix our read loop. Right? The same read loop has to happen over here. But nice if this was like a function here, right? Could make it a function to read the file and give us back vectors or pass it vectors, and if we pass them by reference, you can load them up. We don't really need the vectors for this part though, so I feel a little bad. Let's see. Ticket 42 for Eric. Cool. Confirmation code. Ticket number 1 for Eric Chinesky. Confirmation code. Ticket number 0 for Eric. Confirmation code. Seems like it's reading okay so far.
The confirmation is
So it's going to be the same one because we didn't seed random. So every time you run it, you get that same code the first time. So probably want to seed random. So 4 to quit. So we can go seed random. Is it sran with time 0? I think that seems right. That sounds right. Now we should get some better confirmation codes. Should we try another show? How about Taylor Swift? And she's got what, like 50,000? That went pretty quick, right? For the report for Taylor Swift. So the slow part here is actually outputting to the screen, not reading the file. Right? In terms of how fast things happen, outputting to the screen is actually really slow in the console here. There we go. There's all the tickets. Should we buy a ticket? So let's sell a ticket for Taylor Swift. See, it read it that fast. Right? It was outputting the file that was slow, or outputting the screen that was slow. What ticket number do you want? Who wants to see Taylor Swift? 29,450. What's your name? Bob. Oh, and we got stuck. All right. All right. Let's see. So ticket number, ticket number. Oh, I only did the grabbing the garbage if it was bad here. I got to do it up here too. Because if this was didn't run, we never grabbed the garbage off, right? All right. Try one more time. Forgot I record this stuff, so I should use fake names. It all goes out on YouTube. All right. Taylor Swift. Taylor Swifty. Nope. Taylor Swift. Stuck again.
Taylor Swift's going to see this video.
Let's see. We don't sell for that show. Should we go back? Oh, now my input here for choice. Right. No, I did. I did get line to get rid of the garbage. She got choice again. Why did that one loop forever? There's 2, right? Get the show name. You got the show name. Return the show name. And it just looped forever. Why did that loop forever? What did I do wrong? Taylor Swifty. So it was no good. Right, so now we should be back at choice is not 4, right? Choice is 2. I'm about to get the choice here. I'm off now. So now when I'm trying to get line, it's not working. Taylor Swift. It's the show name. You also take us for that show. Nothing else should have happened. That was it. We're so close. And then the loop stopped. Came back up here. And it should have asked for choice. Somehow it already has two there. Uh, what? I broke it. Broke it real good. I guess pause didn't work. Let's try that again. Choice is two. All right, run that line. Give it two. Goodness. Oh, I can't. I can't make it work. All right, continue. All right. Two is okay. Now we can enter the show name. Taylor Swifty. Now we're back to choice again. How do we get back to choice again? We can also take us for that show. That's fine. Back here. Two. And now we're on the get line again. How is it out of order? I was able to grab choice somehow from the input. So close. So close. That's what we get for trying. Why did it break? Choice. We shouldn't have had a two there. I'm real confused. You can tell, right? Choice is not four. All right, so the first time this works, we give it a choice number, and we give it a show. Let me put the breakpoint like back up here. If we don't test it, still take us to that show. Great. Choice is two. All right, just waiting for their option. Two. Choice is two. Get the show name. So let's step into our show name function. Now it's working. It was not working before, right? Am I going crazy?
It immediately went to the option or option view.
Yeah, like it. Oh, so now it already did the get line. So it already had the show name. What is show name then? Show name's blank. It had a blank. Somehow we didn't pick up that the show name. It picked up the enter key instead of the show name. But it shouldn't have because we got the garbage off the input already. We've got like too many something here. Two. Swift. All right, it's reading it. I don't know what was happening. That's super weird. All right, ticket number one, Eric. All right, I print the report for Taylor Swift. I'm gonna pause here, I think. Can I pause there? Oh no, I ran out of space in the buffer. So I'll just kill it. So the file should have it here. So that's only 576K. Not even a super big file for 50,000 lines, right? So we see I have ticket number one. I can go scalp my ticket and make double my money for scalping tickets to Taylor Swift. Oh wait, no, sorry, I should not recommend that because that's illegal. Sorry, I take it back. I do hate ticket scalpers though; they are scum.
Sure.
Yeah, the whole thing that there is this like cottage industry for it is obnoxious. All right, you okay with the project? That makes sense? In three parts. All right, awesome. Let's start up some new stuff. And what chapter is that? iBooks. Chapter 8. classes are lots of fun. It's one of my favorite things in object-oriented programming. And there's a lot to it. So it goes pretty quick though. Don't worry too much. And then again, we come back to this as a big topic in 200. So we're sort of only like dipping our toe in here. This is chapter 8, classes. So the idea with classes is we're sort of introducing the object in object-oriented programming. You might have heard that term. I think we've thrown it around there. C++ is an object-oriented language. We don't talk about it too much here, but that's okay. So the idea with classes and objects is when we talk about how to solve problems, it makes sense for us to talk about things in ways that we understand. Right? The code's for people. Right? I think I harp on that often enough. You don't write the code for C++. Now, it has to follow the rules of C++, yes, but we write the code so that you and I can read it. Right? And when you do bigger and better things and move on, whoever has to follow after you has to be able to read you the code that you wrote. And they're probably a psychopath, right? You don't want to upset psychopaths, right? So make sure you have nice code for them to work with because it's very expensive to pay developers to write code. So companies want to get their money's worth out of that return on investment. So the longer they can use that piece of code, the more return on investment they get, right? That's a pretty simple business proposition there. So if they pay you to write it and it works for years and years and years, they're getting some pretty good return on investment there, right? Now, sometimes you have to maintain it. You have to update it. Things change. You have to do small tweaks. That's the maintenance. So later on, when you talk about software engineering, the software development lifecycle, most of software's life is spent in maintenance. That it is out there running, and we just have to maintain it every now and then, depending on what it is. Right? It's not too bad. That's generally where software lives, and that's where companies want it to live because that's where it makes them money, is in maintenance. Right? They don't make money on software when they're building it. They don't make money on software when they're getting rid of it. Right? If you ever wonder why banks and government places still use really old, antiquated software, because it's very expensive to replace working software. Can you imagine going up to the boss being like, "Hey, I want to spend millions and millions and millions of dollars on a project." They're like, "Okay, what's our return on investment?" Zero. We're replacing working software with more working software. They're gonna look at you like you're crazy, right? Like, you're gonna spend millions of dollars to make me nothing? Sure. And yeah, and if you get it wrong, that's high risk, for sure. So stuff like that's very expensive. Now, there's all other sorts of things, and we can get into those equations later and maintenance and things. But um, if you remember, there's this language called COBOL from way back when, um, and object oriented since 2002. So COBOL has been around since what is it, 1970s or so, and COBOL has been a dying language before I was in school. Has been a dying language. It's still kicking because there are systems that run COBOL and they still run. Again, it's very expensive to replace things that already work. So, I believe one of the states, I forget which state, one of the state's unemployment systems ran in COBOL. And back in 2020, when lots of people got unemployed all of a sudden, their systems couldn't handle it. And they were desperately looking for COBOL programmers to help the systems limp along. So if you knew COBOL back in 2020, you could make some pretty good cash on these like contract assignments to go and fix things for people. It was kind of funny. Um, Weirdly enough, this is my brother's first job as a programmer was in COBOL, and he absolutely hated it. And then he quit his job and got into professional gambling and played poker online and made a bunch of money until they shut that down. And then he went back to software engineering. It's like, all right, I guess I got to go back to this. So, and now it's legal again, but you can make pretty good money as a software engineer and not have to gamble. And it was a lot of work too. I watched him one time. It was nuts. He played 16 hands at a time of Texas Hold'em, like all and just anyway. You don't have to work that hard as a programmer. That was pretty intense. So COBOL is an old language. It still is object oriented, but this idea of using objects and writing code for people, right, so that it can be maintained and understood, is that we can talk about things as objects because that makes sense to us, right? If I say a tree, all of you know what a tree is, right? That's a noun. You understand trees. Trees have different attributes, right? There's things about trees, right? You might know the color of their bark. You might know the height of the tree. You might know whether or not it has pine needles or if it has leaves. You might know the color of the leaves. Any other sorts of things like the type of tree, any of those attributes, are distinct to that tree. So I can talk about the maple tree right over there, or I can talk about the pine tree over there, or I can talk about the tree over there. And you'll understand those are just different types of trees, different instances of trees, different actual trees. So when we start writing classes and using objects, it's the same idea. I'm going to define a general concept of something with its own unique set of attributes, right? So if I wanted to make a class like ticket, so a class for ticket here, right? The attributes of ticket that we just talked about here, right? We're going to have a private section and we're going to have a public section. We'll come back to that in a second here. But the attributes of ticket here, things about ticket, it has a ticket number, right? Each ticket has its own unique ticket number, right? So you can have 50 different tickets and you understand that there's 50 of these tickets, right? They're not all the same ticket, right? And we might have a string for the customer name, customer name, and we might have an int for a confirmation code, right? So my class for ticket here is defining what is the ticket object and what attributes does it have, right? These are the attributes. Now, this private idea here is one of our fundamentals of object-oriented programming is you don't give people access to your attributes directly because we don't trust people. People do bad things. And we want to protect our attributes and make sure that they're only accessed and changed in ways that we want to allow. If you make them public, anyone can go and change them, right? So we'll put them in the public section here for a second, and we can see what that looks like. So if I say these are public attributes here, what I can do is I can create tickets now. So I like we had, hey, this was a string for name, right? Name. There we go. Oh goodness. Okay. So notice how string shows up in this like kind of light greenish color. String is actually a class. It's kind of a special class in C++, right? That's why you can say name dot and you can do cool things. Because string is a class, right? With integer, right? If you had an int for number, you can't say number dot. There's nothing that happens here. So what it lets you do is add functionality to the class. And we're going to look at that in just a minute here. So if I have a ticket and I want a ticket, I'll say ticket. This is Eric's ticket, right? So now I've created a ticket. This is a type of ticket. I have an instance of ticket here. So this is a ticket object. So when you create and load one of these types of classes in memory, you have an object, a ticket object. We've created an instance of it. And now in memory, somewhere out there in my computer has a ticket number, has a customer name, has a confirmation code, all for Eric's ticket. I can make another ticket for Jeb's ticket. And now Jeb's ticket has its own unique set of ticket number, customer name, confirmation code, right? You can have two different tickets loaded in memory. We could have a gazillion of these loaded in memory. They're all unique instances because each ticket has its own set of attributes. Then we can do, I can say Eric's ticket dot. When I put the dot in, I get access to anything that's public. So these public things here are confirmation code, customer name, ticket number. So confirmation code equals 1234556. Eric's ticket dot customer name, Eric Chernesky. Eric's ticket dot the ticket number. I want ticket number 0. I want the front row seat here for Taylor Swift. Right? You know how much money that would sell for? Front row tickets? My goodness. All right. Anyway, I mean, it would be an amazing show to go see for sure. All right. So we are able to group all these things together here. So one of the terms that we use is encapsulation. It's our technical term. So we're encapsulating all the details of ticket together into one nice, neat little package. So we put all those details together into a ticket class. Now, I mentioned we probably don't want these things to be public here because now I can go and change my confirmation. I can say, hey, instead of ticket number 0, I want to be ticket number 27. If I have access to Eric's ticket, I can go change any of these attributes. And usually that's not a good thing. Right? One of those things we want to do when we encapsulate all the details, we want to protect our attributes. We want to make sure that people don't change them to things they shouldn't change them to. So if I move these all to the private section, now at compile time, I cannot go access them. There's no access here. It's inaccessible here. We can't go get to it. So what we have to do is we have to write public functions that people can interact with. So when we talk about object-oriented programming, we're going to encapsulate all the details, and then we're going to write public functions that give access to the attributes and give us functionality here. This idea is abstraction. It's a fancy term again. So abstraction means people are going to work with my class only through the public functions, only the things that are public. They don't know any of the private details. All they know is the public functions here. And That's actually what happens with string, right? Do you know how the string class works in C++? I got no clue. We could go look it up if we cared to, but because it's open source, but we don't need to know, right? That you can do name dot was it length, right? You don't need to know how it figures out the length of a string, right? You don't need to know any of those details. All you need to know is there's a public function that does that for you, right? And that's how most software works. You don't need to know the details. You just need to know what the public interface is, or an API. It's application programming interface. It's another fancy term here. Whatever the API is, it says, I will do this for you. You just ask for it. That's all an API is, right? Here's the list of things you can do. Go for it. Have some fun with it. So we're going to write our public functions so people can interact with our code. Now, these are really obnoxious to have to do. Let's see, do I have? I don't. So generally what we want to have is ways to set and ways to get. Those are pretty common. So if you want to set the value or get the value, right? So I'm going to have a int for get ticket number. Now I'm just going to do all these methods in line. Later we'll look at how we can split these things up and create other files, and we're not there yet. So all we're going to do is return my ticket number. So inside the class for ticket, I can return the ticket number because this ticket number attribute is accessible everywhere in my class, right? The scope here is this set of curly braces. It's accessible anywhere inside the set of curly braces because that's where I defined it. And then I'll have a string for get customer name, and we'll return the customer name, and we'll have an int for confirmation code is a return confirmation code, right? So I can get those values back out now. So instead of dot confirmation code, I'd say dot, and now I see here's the, oops, sorry, that should be get confirmation code. Confirmation code. When I say dot now, I see here's the public functions that I wrote. You can get the confirmation code, you can get the customer name, you can get the ticket number. But now I can't assign to those yet, right? Because those are all get methods. I can't go assign anything to it here. So I need methods that let me change these values. So a lot of times people call them set and get methods. If you want to be fancy, they're accessor and mutator methods. You access them or you mutate, you change them. I think those terms are silly, so I like set and get because they're a lot easier to say. So set methods are generally void, right? They don't return any values here. We're just going to set a value. So I'm going to have a set ticket number, and you need an argument here for the ticket number, right? So I need to know what the ticket number that I'm setting is to get to this ticket number here. So use this funny syntax here. So this ticket number equals the ticket number. Let's see, I think that's doing it for me. Ticket number? Why didn't that turn gray? Should have turned gray. Ticket number. Oh, I misspelled it. That's why. Ticket number. There we go. No? Okay. So Visual Studio is trying to help us out here a little bit. So when I click on ticket number here, notice it highlights the ticket number up here. So ticket number is the parameter ticket number. This and this crazy little arrow syntax you're going to love in C++ is this instance's ticket number. Right? Notice how it doesn't highlight when it's hovered over, it highlights this one here that's in use. So this ticket number is this instance's ticket number. Ticket number here is the argument ticket number. This is known as, I've shadowed the variable because I have the same variable name here. Some people think this is bad. I think they're just lazy. This is much better to have this syntax here and use the same variable name because it's very clear what it is. So now I can go and set the ticket number. So I can say Eric's ticket dot set ticket number. And because I called the variable ticket number up above, I see it saying, hey, the variable you need to give it is a ticket number. So I can set the ticket number to 0 here instead of assigning it this way, right? And I'm going to have a void for set customer name, given a string for customer name. And it'll be this customer name is equal to the customer name argument, right? It's always worth double checking, make sure they highlight correctly, make sure we get the right ones here. Because if I don't have that, if I just say customer name equals customer name, now it's all three of them are the parameter. So now I've set the parameter back to itself. Nothing is actually happening here with this. So it's worth making sure you're doing this the right way with this arrow notation. It's a little wonky. We'll get used to it. Don't worry. And then we'll set confirmation code, int for confirmation code, like this confirmation code equal to confirmation code, right? So now instead of directly accessing them, I'm going to use my set methods on each of these. So Eric's ticket dot set confirmation code 123456, and then Eric's ticket dot set customer name Eric Chinesky. Now you probably don't think this is worth it, and that's fair. We've done a lot of work to not get anything different. The functionality is exactly the same. All I've done is set some values, right? But now I'm using my public functions for them rather than accessing them directly. Now, the power of this, what the benefit of this is we can start adding some sanity checks. Because they can only change values through my public functions here, I can make sure things are valid. So I can say, hey, if my ticket number is less than 0, then I'm just going to say this ticket number equals 0 or something. Otherwise, maybe I'll accept that value. Right? If they give me something that's less than 0, I'm not going to have negative ticket numbers. I'm just going to say, nope, it's probably 0. Right? So we can start adding some protection around our class, around the attributes of our class. Like, what are valid bounds for this? What's a valid range for this? For confirmation code, if ticket should be the one that defines what confirmation code is, I don't even need to give them access to a set confirmation code. Maybe I just have a void for assign random confirmation code that takes no arguments. And I could say, hey, my confirmation code then is going to equal rand mod 900,000 plus 100,000, something like that, right? If I don't want to get them access to it, I don't have to. There's no rule that says you have to be able to go and set these values here. So now I can say Eric's ticket dot assign random confirmation code, right? It will go and randomly pick one for me based on the rules the ticket class has defined. Again, it's a little silly because this is all my code, but the idea here is as software gets bigger and bigger and bigger, working on bigger and bigger and bigger projects, you can start to break work up. And that idea of functional decomposition, now we've introduced classes here, and we can have different people work on different classes. Okay, I'm going to work on the ticket class. You're going to work on the kiosk class that actually goes and sells tickets. Here's the public functions for ticket. Go nuts, right? And then I can worry about how tickets work, and you can worry about how the kiosk works, right? We can break things up more easily this way, and we're kind of make sure that the classes protect themselves, right? They maintain the integrity of their own attributes. If it shouldn't have this particular value, don't let them do it. Right? That's all it is. All right, we're about out of time here, so we'll come back on Wednesday. We'll finish up talking about classes. If we don't finish all of it, that's okay. We'll have a little bit of time. We can finish them up if we need to. We'll work on classes in lab today. It'll be lots of fun. We'll just do a basic one. I think we'll be in pretty good shape. Next week we're off for the whole week for Thanksgiving break. Hooray! Um, hopefully you can work on the final project though. If you want to have more time during finals week. Maybe that's a bad trade. Maybe that's a good trade for you. It's your choice, right? That's the fun part there. Then we'll come back. We'll talk about pointers. I don't think we'll take the whole the whole time for pointers because again, this is a topic you'll do a deep dive on next semester in CIS 200. Hopefully, you've registered already. I think that opened up now for freshmen by now, right? You kind of had that delayed start. The 15th. Oh, okay, very soon then. For registration for you, and then the last week of class is just work time for the final project. Okay, and then you'll present. I gotta find out probably in this room. I'll have to see that they schedule it weird. We'll see where we present, and we'll be done. So we got a little less than a month left now. Okay, we're in the home stretch. Any questions, thoughts, concerns? If not, I'll see you on Wednesday, or see you in lab. Right, lab today, class Wednesday. All right, thanks.